All right,
I'm
it's
ready.
4, so we're gonna get started. So welcome back to Buckle Up with Mike and Brian. Both of them are here this time, which is awesome.
Live.
Today we're talking about troubleshooting motors. So if you have any questions at all about troubleshooting motors, be sure to leave them in the chat and they will answer them.
Yep.
Before
and
we
thanks
get
for submitting your earlier requests.
Yes, before we get started,
I didn't get to look them up.
our next Buckle Up is on June 10th at 4 p.m. for VFDs. And Brian, what does that stand for?
I don't know, Jess. What does that stand for? Variable
Inverter.
Frequency?
frequency
Inverter.
I don't know.
drive.
Speed
Drive.
drive. Freak drive.
That's our next topic, so be there. Also, big thing, today we hit 10,000 followers on Instagram, which is crazy.
Sweet.
Last year we were at 2K, so we're growing like crazy, and thanks to you guys who are
Thanks,
following
guys.
us. That's freaking awesome.
Yeah, big time. Big time.
Wow. All right, I'll pass it over to you, Brian, if you want to start sharing your wisdom.
So, you know, my opening Smart Alex stuff, I'm not Mike, and welcome back, brother. It's time to
Buckle
buckle
up.
up. So, as Jess said, we're going to do a segment on motors, and I'm going to do a little piece with Mike, and we're going to show you, give you a rough idea how to check the windings for open winding, shorted winding, and grounded winding, and what to look for. So I have a courtesy of Mike and his ability to take things apart for me. I have a couple of motors sitting here. These are what, 1/3 horse motors? They're
Permanent split capacitor motors.
with permanent split capacitor motors. But I wanted to be able to show you, so thanks to Mikey, that is the rotor.
I'm going to zoom in
Set
here.
that over there. Okay, sorry, that's the rotor. That's the spinny part.
The
This is
rotating part.
This is the stator, and these are the windings. So when you're checking a motor winding, that's the copper, and if you look at it, it's wound, 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 wound. So that's got windings in it, and that's where and then down inside, hard to see, but those are the
Rotor bars.
thank you. That was the word I was looking for, was the rotor bars.
Here, I thought
So-
I made it up.
No, you didn't make it up. That was the word I was looking for. Thank you. So what happens a lot of times on the windings, you see these are all nice and shiny. And when we talk about having a burnt motor or a grounded motor or shorted motor, if it's shorted, it's going from winding to winding. It's hard to see here that it's two different loops that we're looking at, or in this case, here's one loop, and here's one loop. So a winding to winding short doesn't necessarily mean that it grounded to the case or hit the rotor bars. What it means is that the windings burnt and they are touching each other. And how you would see that, and that's where I'll let Mikey use the meter, is if, I think it's still on ohms, Mikey. For you guys, ohms is the upside down horseshoe looking thing. So if it was to be a shorted winding, I believe now you have a 0 point something. That means that the windings are shorted or touching each other. If the winding was open, when you check your lead, the windings are open, not making connection. And then grounded, you would go from one lead and actually touch the ground of the motor, or if the motor's installed, and you probably are reading OL on that.
Yeah, in a lot of cases, you'll have a wire coming from one of the screws that go through here that actually goes to ground. So you can read there as well.
So if it was, and I will simulate that, if you had a winding that was shorted, and I'll try and simulate that. If you had a winding that was shorted, by hooking up your lead to one wire and then touching chassis ground. Now it doesn't read OL, it actually has a reading, which means that the winding itself is grounded to the chassis of the motor. Touching ground, aka grounded motor. And the same thing goes for, I mean, these are fan motors, but the same thing goes for a compressor. I can't pick up a compressor anymore, and I was taking it easy on Mike and didn't make him drag one up there. But the same thing goes for motors. Now these are two wire or 4-wire fan motors, meaning that 2 wires go to power and 2 wires go to the capacitor. If you've got a 3-wire motor, then 1 is going to power, 1 is going to the power on the capacitor, and 1 is going to the capacitor by itself. 3-wire motor. Mm-hmm. So that's my opening statement. There you go. Have at it, guys.
All right.
Did I screw that up?
No, one thing I'd like to hit.
Not me.
No, never you. One of the things about the shorted windings, all you've got is just a mass of copper winding there, and what happens is it shorts together somewhere in the winding, and so you put an ohm meter on there, and you can still see a relatively same reading between different windings, even if one of them shorted.
Yep.
Partway through. So in a lot of cases, you would pick that up as an overcurrent with an amp probe.
You can see it as an overcurrent. Now, you know, going back to that too, to elaborate more on the windings, a 3-phase winding, if I'm ohming winding to winding, should always be the same.
Yes.
On a single-phase motor, R, or common to R, is a high resistance. Common to start is a less resistance, and run to start is the equal of common and start and common and run. Ooh, how do you like that?
I'll tell you, I'm impressed.
I was too. I remembered that.
I had to go look up the single phase motors. I haven't done one in so damn long.
And so 3-phase motors, if you're reading it, you don't have common start run on a 3-phase motor. It's L1, L2, L3. So what you're looking for is that the ohms resistance, not continuity, ohms resistance between common start and run, when you do that test, would be, you're looking for the same ohm reading. And then ground test is the same.
Ground test is the same.
Yep.
Ready for some questions?
I'm ready for questions.
Yeah.
All right. We will start
What we do.
with the ones that were sent in today. So first one, Jason asks,
Hi, Jason.
Can you explain how to mega ohm a 3-phase 9-lead motor? What are the readings you're looking for?
Well, I go way deep in the weeds. The way I meg ohm a motor is probably different than the way Mike does. If it's the same, I would be really shocked. I don't apply meg ohm power to L1, L2. I read all my meg ohm readings to ground. It's always a ground reference for me.
Yeah, no, definitely. The thing is, with the 9-lead motor, that allows you to change the wiring to go from a 230 to a 460. Huh?
I've got a trick.
You've got a trick?
I do. I have a trick.
Cool.
I have to show the trick.
Mike, someone says, has Mike been in the sun?
Oh my God.
I spent 3 weeks on rooftops in Phoenix. One good thing about Phoenix, I walked up to a hardware store and there was a big sign on the door that says, masks are optional for people who are vaccinated. And I said, yeah, baby! And off came that mask.
So this is a perfect 9-lead motor. All I did was open up my phone and bring up the calculator. Here's a little put it in your pocket trick for a 9-lead motor. If you're wiring it for high voltage, you wire, and this is hard for me to see because I have one of them smokes, you wire 4 to 7 together, 5 to 8 together, 6 to 9 together, and power goes to 1, 2, and 3. That's for high voltage. Your low voltage is 4, 5, 6 get tied together. 1 goes to 7, 2 goes to 8, 3 goes to 9. And that's where you hook up your high voltage leads.
You know, since we're talking about three-phase motors, you know, one of the drives was a really big thing in my early days. And one of the biggest problems we would find was on the connections between your like 5 and 4 and 7, 5 and 8, 6 and 9. The wire nuts would come loose, and there was enough of a resistance there where it didn't blow fuses. You just got really weird imbalances and things like that. So a really good thing to do is to open up that junction box and look in there to check connections and make sure they're good. I don't know how many service calls I went out on where they said, oh, the motor's bad, the drive's bad. Pull the cover off and see the wires burnt. Clip them.
Loose connections
Yep.
in the pecker head of the motor.
I was avoiding using that
I
term.
know you were. I know you were, but the guy's got to get used to it. It's
I use that term in front of some young ladies, and
they get upset.
Oh, they got upset.
But that's truly what they call that cover.
Yeah.
And yeah, on the smaller fractional motors, well, not fractional horsepower, but the lower your half horse, your 1 horse pumps, all the way up to like a 5 horse pump, the pecker head really isn't big enough to do. But I think some guys call them the Kearneys.
Yeah, but they'll have a little tiny thing here that they can either.
But yeah, you got to use wire nuts.
Yeah.
Because I like to do the clamps, the split bolts.
They got new things now.
As long as you got enough room for them. I can't think of what they call those either.
I can't either. They came out with those really bitchin' ones that had the.
But it's got the insulator and the whole bit.
Yeah, you pull the different plugs and
yep.
then just wrap a little bit of tape.
So tell me what that is, guys. That's
I forget.
Technology within the last 10 years. But split bolts is all.
Come on, guys, tell them. Leave it in the chat. What is it? We're waiting.
Don't you wish you would ask that question? We'd be sending you a package right now because it stumps both of us. But we came up with it ourselves.
Here we go.
How's the teeth?
Good.
Ready for the next one?
Always.
Oh yeah.
All right.
Did I answer Jason's question though? Man,
I wouldn't know.
I rambled. Read me his question one more time and I'll.
Can you explain how to mega ohm a 3-phase 9-lead motor?
Yes. So I did not complete that question. Thank you. So how I do it, Mike agreed that that's the way he does it, is you take 1 lead from the mega ohm meter to ground, and it's a ground reference. What should that be? Depends on the horsepower of the motor and what its atmosphere is. If its atmosphere is air, meaning it's out in the open, I would expect to be no less than or no more than 500 to 1,000 megohms is what I would expect to see, because you're testing the resistance of the winding, you're testing the insulation, so it's actually how much power goes to ground. And a true mega meter is 1,000 volts.
Yeah.
How many ohms is a mega ohm?
Million.
Oh, cool.
1 meg, 1 million.
1 million.
Cool.
So see, you can teach us old guys scientific stuff.
I don't know about that.
K is 1,000, M is 1,000,000. So a meg ohm is 1,000,000 ohm.
You know, back to his question though, when you're reading phase to phase, your meg ohm's not going to do anything because you're looking for a real high resistance. You're not going to see that on a phase to phase.
Yeah, I don't do phase to phase meg ohm readings. That only opens up that winding. It subjects to that winding to 1,000 volts and will probably start breaking down the insulation. So taking, for example, L1, L2, L3, taking that and making a reference. And that's really what it is a reference. If you're using it as a diagnostic tool, it'll tell you if it's grounded because it'll get down below 500 megohms. Pretty much it's grounded in a dry atmosphere. I use the Megers for chiller work, centrifugal work, and we had to baseline that machine every year. And doing the mega ohm readings, it was a reference from L1, L2, L3 to ground and recorded so that we could see if the winding itself was starting to deteriorate.
One of the places I came into it a lot was on cooling tower fan motors and that, because the drives would go off on a ground fault, and it was because of the fact that there was breakdown in the windings, and the moisture would conduct.
Yep.
And so, you know, I mean, I've had people say to me, you know, Mike, I got a really low mega ohm reading. Did you get a call on that? No. Are you having problems with anything? No. I'll let it run till the motor burns up. You know.
And it's the same thing. You get into my centrifugal motors would be anywhere from 650 to 750 mega ohms.
That's different. You want to find that before you put the damn thing back together.
Well, no, that was refrigerant in it. So we were doing our annuals, oil changes, and things like that, and we were just taking the baseline reading and comparing it to last year's baseline reading, and that's where you see it starting to break down. So if last year it was 725 and this year it's 575, we know that motor is going to have to come down.
Yep.
Because you don't want them to fail.
No.
That would be bad.
That would be bad.
That would be bad. Okay, thank you, Jason.
We have another one that was sent in by Steve. It's a little bit lengthy.
Okay.
Oh, can I summarize that one, Steve? Thank you very much for submitting the question. Fantastic, beautiful description of what you're looking for. What Steve has is a train unit.
Okay.
And Steve, the term is soft starter. So I know what you're trying to do. You're trying to start the motor slow so that it quits burning up the belts. You can also try putting in a cog belt instead of the standard A or B. You can go with a AX or a BX belt, and that might help you as well.
Also
stop chewing up. His tension is good. This is all in his story. I'm sorry.
Okay.
His story is he's burning up belts, and everything's lined up. Everything's properly tensioned, but due to the torque at startup, the belt still squeals and burns rubber.
In that case,
so what he's asking to do is his thought, which is a good start. He doesn't. The term he used was a slow starter, so that's why I corrected. The term is actually a soft starter because you're not using the VFD to maintain anything other than taking the motor from 0 RPM all the way up to 60 hertz or its full capacity. They call that a soft starter. So in his question, and he's going down the right road, is what would be a VFD that you would use for that application, the manufacturer? And I know AC Tech makes them, ABB makes them, Yaskawa makes them.
VFDs or soft starts?
Well, he asked specifically for a VFD.
Okay.
And I know that you can use a VFD to either maintain static amp draw, but you can also use it for a soft starter, 0 to 60 hertz.
Yep. Yeah, Benshaw, ABB, Septronics, they all make dedicated soft starters.
Dedicated soft starter.
Yep.
And then I know AC Tech, Yaskawa, and ABB, they all make a smaller VFD.
Yeah.
So I don't recommend any one over another. I've worked on all of them. Mikey, you've cut your teeth on Danfoss, ABB, Yaskawa.
Parametrics. Let's go back 100 years.
Parametrics. Yeah, I know. So use what you're comfortable with. If you don't know anything about any of them, the easiest one to program for me was Danfoss and ABB. Those were the easiest ones to program. So, thank you, Steve.
Okay, next one. How do I check a motor to see if it's grounded? I don't know if we went over that already, but
I did, but it's a fair question, and Mikey, you'll do it again.
Yeah. Basically, disconnect your leads from power and connect your ohm meter with one leg to ground and with one leg to the windings of the motor. And the reason you want to disconnect them is because if the ground is, let's say that there's a ground in one of the wires going to the motor, I want to isolate that out of there so I'm actually reading the motor to see if the motor's grounded. Because I don't know how many times people have changed out a motor and they put it in and they're like, wow, the new motor's grounded too. Well, it wasn't the motor, it was one of the wires in the wiring harness going up to the motor or someplace.
Miss Jessica, to prevent me from standing up in front of the camera, can you go over onto the Studio B shelf and grab the contactor from last time? That one right there, beautiful.
I know what a contactor is now.
Yeah, and she
learning.
remembers.
We're going to get you a pink tool bag.
She
with some
remembers.
tools.
She remembers.
I'm learning.
You are.
So, here. Picture this, guys. Picture this. Your motor is connected to the contactor. What Mikey just told you to do was disconnect the wires from the contactor, grab one of your leads and put it on the wire. Your other lead is connected to ground. In this case, I'm using the motor. And then you look at your meter and you see that you're not doing a reading. If the motor was grounded, keep an eye on that meter.
You got it?
If the motor was grounded, now you have an ohm reading. It doesn't say OL. Thanks for the question.
See, a lot of times, one of the things that you'll run into is like where the wires go into the motor and stuff like that. They can rub, and they'll turn around and they'll go to ground, and so it'll give all the indications of being grounded when it's not the motor, it's the wires going into it. So be careful of that.
And I will caution you as well that if you were to do that on a compressor, take your leads out of the contactor and read to ground, and then you show an ohm reading. The next step, don't just automatically condemn that compressor, because the compressor has prongs on it as well. And you can burn a prong and that wire is actually touching the case and the compressor's not grounded. So always, if you see it at the contactor and go, oh, I got a grounded compressor, then always go get the cover off of that compressor and physically look at it, disconnect the wires at that point and read it.
You want to get as far into it as you can. At the terminals on the compressor or the terminals in the motor, you want to get in there so you don't have a lot of other things that where the ground could be.
And the reason for disconnecting it is so that you're not reading other motors or other components in the system. You want to make sure that you're isolated to the component you're testing.
Yep.
Ha.
I like that one. That sounded good.
You got a nice presentation. Love it. Thanks. Good job, Brian.
We try, guys. It's all that we can do. I can't make this any better looking.
Yeah, I'm gonna lose 10 pounds tomorrow. I'm getting a haircut.
Get a haircut.
I'm getting a haircut.
I can't afford to get a haircut. There's not much up there. I said, I can't make this look better.
So if you have any motor questions at all, leave them in the chat and they will answer them. We'll answer a few more that were sent in today. So what happens to a motor if the capacitor goes bad?
Ooh, I like that one.
Ooh, that's a good one. Go ahead. You dance on that.
Why
one
is
for
that a
minute.
good one?
Well, because it's a permanent split capacitor motor. And what the capacitor does is kind of causes a phase shift. And so the one phase is chasing the other one, which is what gives the motor its torque and to run. If you have a weak capacitor, and we just had one in Phoenix, where it was like a 45 ohm or 45 microfarad capacitor, and the compressor wouldn't start. And I told the guys, I says, check the capacitor. It was like 12 microfarads. They swapped out the capacitor, compressor started right up.
Yep.
Because it's shifting the phase to get the compressor or the motor running. And so
And you're getting a little boost out of it.
Yep, and so if the capacitor is weak, you're not getting anywhere near as much boost or as much phase shift.
And the other thing too with permanently split capacitor motor is if the capacitor goes bad, and I see this a lot on condenser fan motors, it can do one of two things. It's going to sit there and hum, vibrate, not turn. But the other thing I've seen it do is you get these things on a roof and the wind, there's enough breeze that the motor actually starts spinning backwards when the unit calls for cooling. And when that happens, the motor will continue to go backwards, and instead of pulling through and out the top, it's like sucking.
Yep.
And so your indicator is to look at the capacitor. Not all bad capacitors go pregnant.
No. Nice terminology.
Not all of them poof out.
No.
They're great to see. It's a fun thing to see, and be thankful that the powers that be that make capacitors putting that PCB stuff in there. That black, nasty, stinky, oh yeah, burn stuff.
Now there's two things that I would consider, maybe three, when you're looking at a capacitor. Brian hit on number one, as the capacitors will get all bloated and kind of blown out. Another thing you'll see sometimes is leakage around the terminals.
Oh yeah, oily.
Yep, you'll see that. The other thing you'll see is corroded terminals. If you've got a problem like that, I mean, a capacitor is $12, $15, worst case. And to save, you know, an $800 or $1,000 compressor, it's not a bad idea to change them.
You know, I had a call the other day. I know this has nothing, but you were talking about the terminals, and that made me remember this. The machine was only 2 months old. They installed it 2 months ago, but, and you've seen this, they come off two pressure controls, high pressure and low pressure. So off the control board, it goes to the low pressure switch. From the low pressure switch, it jumps over to the high pressure switch. So that wire, those two wires, were put together with a connector. So it had the stake-on and the stake-on. So they put a stake-on jumper with plastic wrapped around it and plugged those in. The board would not allow the contactor to pull in. So in talking to this guy, I got him to unplug that connector and read he had 5 ohms resistance.
That's a lot.
That's a lot.
That's a lot.
He had 5 ohms resistance, taking the wires off the board. So he's got one wire, goes to the low pressure switch, jumps over to the high pressure switch back to him. And he's reading that. And that was 5 ohms. Unplugged that connector. He read into the one that would be feeding the low pressure switch out of the low pressure. He had 0.03 ohms across the switch. Perfect. Do the same thing for the high pressure switch. He did that one, he did that one. He had 0.8. Took that, put them back together, he read it again, and it was 5 point something. And as I said, take that apart and then strip the wires and put a wire nut on. And his final number was 0.9. So the connector, the corroded connector,
You know,
2 months old.
One of the things I saw there in Phoenix, and I just wanted to kill some people over it because I got the shit shocked out of me.
You get burnt?
I got burnt. On a lot of these motors, they'll have a pair of wires coming out that have got connectors on them, and you can swap the 2 wires to change the rotation on the motor. Well, there seems to be this trend where they take those wires, those stake-ons, and they stick them up through the grill.
Stick them up through the grate.
Yeah. Well, you get there, and all the plastic's gone. And now it's just nothing but bare metal and sticking up there, and you lean up against that thing, it'll let you know it's there.
Yeah.
Someone said you guys rock. Just got my blue-on hat in the mail.
Sweet.
Super nice. Hell yeah.
Wear it with pride, baby.
There we go.
All right. So I don't know if you guys are done with that explanation or not, but
I am. Sorry, I went off on a tangent, but
it's okay.
my point to that whole thing, and we're talking about motors, and we're talking about ohm readings, and you can have 24 volts, and you got to watch the resistance. The switches were closed, and the switches tested out right, but when he put it back together, his ohm reading was way too high.
You know, one thing I want to hit on, because I've run into this so much lately, is people will take their meter and they'll reference ground, and they'll go to one leg of the motor and they'll read and they'll say, okay, I got 120 volts here, and then they turn around and go to the other leg and they say, I got 120 volts here, but my motor doesn't run. Keep in mind that this motor is just a winding, and this motor, I'm not sure if it's 120 or 230, but the thing is that you require that full voltage. So if I've got a 230 volt motor or 240 volt motor, and I read from one leg to ground and then the other leg to ground, and I get the two 120s, it's like, wow, I got my 240.
But do you actually
You
have
don't
240?
necessarily, because you're reading, because this point here is the same as this point here.
Yeah.
Because it's just a coil of wire. So what I'm saying is, when you go to check to see if you've got voltage to the motor, you want to go across the two wires. You want to see what the voltage is there. Not to ground, but the voltage across there. Because if it's 240, you want to see 240. So,
And we see that a lot when guys get confused on color. You guys talk to me on the phone, I've told you before, voltage does not care one iota what the color of the wire is.
you mean red doesn't go faster?
No, doesn't go faster. But if you happen to be, in this case, these are both black wires, and if you got lost and your other motor was a black and a blue, and now you got these two blacks, and you know you want 220, so they need to be, I'll get this contactor back up in my hands. So you want to be one on one side and one on the other. So what Mikey's talking about is, if I read between here, I would have the 230 volts. But by chance, if I happen to hook this up wrong and I had a connector and I put it there, and now I read it, each one of these wires is reading the 120 to ground, but it's the same 120.
Yep.
So the motor wouldn't run until you get it back over on separated, and now it's 230. And we get that, we actually get that call, and it's because of the confusion, guys taking out a 3-wire condenser fan motor and going back in with a 4-wire, or vice versa.
Yep.
And then we're all right. Call us. We'll walk you through it.
Yeah.
How do you check if a motor is working at full capacity?
Amp draw.
Yep.
All right.
So if the motor, how do you check this? How do you know whether the motor is performing at full capacity? If you've got the correct voltage, if a condenser fan motor is rated for 1 amp and you're drawing 0.8 or 0.9, it's running at capacity. If it's rated for 1 amp and you're drawing 0.5 amps, then you can adjust where that fan blade is in the shroud and get the amperage up. Another one is, if it's rated for 1.0 and you're drawing 1.3, you're going to overheat the motor. Again, adjust the fan blade height in that fan shroud to get it back to no more than 1.0.
You know, talking about those terms, I mean, I think there's a couple we got to talk about. LRA, locked rotor amps.
Locked rotor amps.
If you turn around and get locked rotor amps, I mean, one thing that I always do when I go to check a motor is I spin it first, just to see if it's going to spin.
On a condenser fan motor, hard to spin a compressor.
Yeah, but there are ways.
Yeah.
There are ways. There are ways. You just reach in there, grab the
Yeah, whatever. Not an open drive.
Oh, okay. But LRA's locked rotor amps. Full load amps is, if that's a 1 horse motor, then that's the amperage that'll pull when it's developing 1 horse of work, or using 1 horsepower of work. Then there's also a term called running load amps. So let's say they put in a condenser fan motor and they need a 0.8 horsepower motor. So it's not going to run at the full 1 horsepower, but it's bigger than a 3/4 horse. So they're going to get the running load amps, or the design load. So just be aware of that. Running load amps is
RLA.
Yep, is less than, you'll see the RLA.
And locked rotor amps is LRA.
Yep.
There you go.
We got it.
Nailed it.
We still got it.
There you go.
Can Ecm Motors be repaired?
Yeah, you can. You go to the store and you buy a new motor and you put that one in where the old one was. It's now repaired.
Some of them got a board you can change.
Yeah, and that is dependent on manufacturer, because some manufacturers you can separate the board. If you have a bad motor, you can replace the motor and put the same board back on. Other manufacturers need to be matched, So if the motor's bad, you have to change both.
Yep.
And inversely, the same thing. I've seen manufacturers where you can change the control head and leave the motor there. Speaking of ECM motors, guys, go get the tester. I don't care if it's $50, $60. Get the tester. It's going to save you so much trouble.
Yeah. Yep.
Just get it.
Yep. It's.
What came first, the chicken or the roast? I had a gentleman on the phone the other day, and after going over it 3 times, and it's like, okay, we're now both laughing about this. We both know the horse is dead. Do we need to talk about it for 15 minutes? Or are we just going to agree the horse is dead?
Well, you know, one of those.
A bad capacitor is a bad capacitor. We don't need to test it 4 times. It's a bad capacitor.
You know, one of the other things when it comes to 3-phase motors is rotation can be critical, because if you have a scroll compressor or certain other things, if you spin them backwards, you get a few seconds before you kill it.
Yeah,
so
some of them are very, very, very critical on that. That few seconds means, oh, I'm just going to take my pencil and I'm going to mash in the contactor. And in some compressor, if they're running backwards, that's all it took, and you just wiped out the bearing.
Yep. So the thing is, they actually make a phase rotation meter that will show you the rotation generated based upon the wiring.
Red light, green light.
Oh, I might have a little wheel that went round and round and
well,
round.
there's that too.
Yeah. But the thing is, and to change the rotation on a 3-phase, all you do is swap 2 of your power leads, and it'll change the rotation of the motor.
Yep.
So I love 3-phase. It's simple. You don't need to worry about capacitors or any of that kind of stuff.
I know. And, oh well, we're gonna go into that when we get into VFDs. I almost gave away part of our VFD discussion.
You did? Almost. Wow.
Oh, no.
Don't do that.
I can't do that. I can't give that away.
To
Sneak preview
tune in
coming.
to
Sneak
June
preview
June
coming
10th.
June the 10th.
Here we go.
In our VFD class, we'll explain to you which end to swap if the unit is going backwards but your motor's going correctly.
Yeah.
Ah,
And you got the bypass panel or no bypass
Teaser.
panel. Oh yeah.
teaser.
Party time.
Oh yeah, it's gonna be fun.
We have a question from Hey, it's Kirby.
I got the Kirby part.
Is his username. I often see ECM motors fail shortly after removing a significant airflow restriction from the system. Any ideas why?
Because the ECM motor is a torque control motor, and they use torque as the means of controlling the speeds. And so now if you remove that obstruction, now the fan motor is going to move a lot more air, and it's going to pull a lot more current, which can cause the motor to fail.
Could. Yep.
What's the name of the ECM motor tester?
ECM motor tester. Google it.
Well, no, they have.
They got several.
I know.
ones.
Well, Carrier makes one for their units. Oh my gosh, help me out.
X13.
X13 motors.
It's a train.
And but that's also the universal. X13 is a universal replacement for ECM motors, and it's the test tool.
Yeah.
There's no fancy word to it. It's just the ECM motor test tool, and it doesn't matter whether it's unit specific or a universal one that you would find at your local parts house.
You know, I think it's Terrain has got a way that you can test an ECM motor with a 9-volt battery.
Again, Fred.
No, it's actually in their one manual. But the thing is that, you know, there are certain tools that are going to make your life easier. I mean, I couldn't imagine working without my multimeter or my amp probe and things like this. And with all the ECM motors out there, you know, everyone's got its own little different test procedure, but with these ECM test tools, they're set up. There are some universal ones, there's some specific ones, but it just makes your life so much easier to be able to test and know what's going on, because is it the board? Is it the motor? Is it this? You know?
Right, and with the test tool, I mean, you're literally unplugging from the board, plugging into these different universal taps, and being able to power up the test tool and run tests, so you know whether it's the motor or and I wish I knew the manufacturer. The one I saw was a universal, and it actually lights up and tells you what's going on.
I'm serious. I didn't mean Google. I meant Amazon. But you can go on Amazon, and Ecm Motor Test Tool, they run from 50 to 90 bucks.
Okay.
Is what the ones I saw. It's just, you know, as the industry changes, we have to change with the industry. And so I remember with some of the old flame sensing things and stuff like that, where you had to get the box and plug the box in and everything. You know, as things change, we have to get the little tools to make our lives easier.
It's all about making, it's
Yeah.
kind of like why we're here.
Yep, to make your
We're
days
here to make your life easier.
Go on.
So, you know, if you
Plug.
work on a lot of the Ecm motors, get that little test tool. It's worth its weight in gold.
Cool. All right, I'll look for some more questions. We'll start to wrap up here. We're 41 minutes
So while
in.
you're looking at that, don't forget, app 100% free. Our next Buckle Up on VFD's June the 10th. We're still, man, you guys got to be as excited as we are for the forum coming this summer. Man, you guys are gonna love that stuff.
Yeah, you'll be able to find stuff super, super easily. Basically find what you need when you need it. It's going to be a massive breakthrough for the industry. Huge. And it's on the app. And so it's still free, and you're going to have everything in the app that you could possibly need. So it's going to be super awesome. So make sure you have your app on auto update so you can see when it comes out.
And we will be, I would imagine, push notification.
Oh,
too.
absolutely.
Yeah,
Oh,
letting
yeah.
you guys know what's coming. But in the meantime, know it's coming.
Yeah.
The three options in tech support line: manuals, under 20, over 20. You know, kind of like the standard stuff I say all the time. Yeah.
So
We're trying to help you guys faster. So try and select the area that you're in. So, you know, I've got people that I can, that will just look up manuals, but if you're calling the manual line and you have technical questions, that's going to delay getting you to who you need. So that's why we set it up that way, again, to make your lives easier.
And tell all your friends to download the app and follow us on Instagram, because we want to keep growing our platform, as well as like, subscribe, comment, all the usuals for YouTube, Facebook. We're on everything. So just look up
click it.
Balloon Community
Click it. Give me a
and you'll
thumbs
find
up.
us.
Subscribe, hit the bell,
Yep.
leave a comment. All that stuff I'm supposed to say that I'm actually starting to understand.
That's scary.
Yep. I teach Brian social media, and he
When are you
teaches
gonna
me
teach me?
HVAC basics.
When are you gonna teach me?
Oof.
That's-
that's
we
quite
can
a
catch
lift.
you up. We
Take
can
a long
catch
time.
you up.
I don't
We're gonna
know.
wait for your temperature to drop from being stuck in the desert. It's good to have him back, right?
Oh yeah, it's good. Good energy in here. All right, I think we'll wrap it up. So again, June 10th, tell your friends, download the app, all that good stuff. And thanks for tuning in, guys.
Thanks,
Thanks, guys.
Peace.
Peace out.